and part of Chapter 16 of the textbook for this course as presented at the Royal University of Agriculture. I am Dr. Jared Williams, and a soil scientist and, a soil and crop soil scientist with Brigham Young University, Idaho, in the United States of America. Now, let's get in and talk about soil resilience. As part of this course so far, we have talked about a lot of management practices that we can use in order to reduce the impact of our management, or agriculture management, on soil science, on soils. But now we want to look at it from the soil's perspective. How well can a soil respond and return back to its previous state after an event? So if we have some disturbance that occurs, some disturbance on the soil, how rapidly can the soil return to its pre-disturbance state? Okay, and so as part of this section 13 on soil resilience, we're going to talk about, let's see here, let me get my pen going. We're going to talk about what defines soil resilience and why it's important. Okay, so, and then we're going to talk about how we can classify soil resilience, some types of soil disturbance, and some factors that will influence the soil resiliency, and then we'll talk about some soil processes and how they influence soil resilience, and then soil erosion, and specifically how soil erosion and erodibility influence resilience and impact resilience of soil. And in the end, we're going to talk about some indicators, some things that will indicate whether a soil is resilient or not, and then we'll talk about some management strategies for improving soil resilience. Okay, with that, let's talk about what soil resilience is. Let's define it, and I think to start off with, we have a definition here. And really, when we talk about soil resilience, it's the soil's ability to recover from degradation or disturbance. Well, I've been using the word disturbance, but degradation or disturbance, right? Disturbance right there, and return to a new equilibrium. So return back to a state. Now notice that we're not saying the same state, we're saying similar state. So it's returning back to a similar condition that it was previously. Okay? And the reason we tend to use this word, or like to use the word similar, is because in soils it really isn't practical to try and get our soils to return back to the previous pre-disturbance or pre-degradation state. Okay, and so we have that down here at the bottom of our, where's my marker? Here, where we say original state versus not significantly different state. And think of this not significant state as being a similar state to the pre-disturbance. And the reason for that is soils are complex. There's lots of moving parts, lots of things going on with soil, and so to try and actually get it back to its previous state is not really practical, but can we get it back to a very similar state? Okay, and the resilience of a soil, so its ability to return, or we like to use the words bounce back. That's an American way of saying it. Bounce back. Its ability to bounce back is really dependent upon its ability to form soil. Okay, soil formation is the key, because when we disturb the soil, we're probably removing or changing some of that soil, and so how fast can the system form new soil to replace what we disturbed? Okay, in other words, we're not going to correct the soil that's there. We really are more likely to create new soil to replace the disturbed soil. So it really comes down to soils that are resilient. In other words, soils that can bounce back are going to be soils that can form new soil at a fairly quick pace, or that are deep soils that can that some soil can be removed and we still have sufficient soil left. And so that ties into physical properties of soils, chemical properties of soil, and biological properties of soil. Okay, physical from soil structure to soil texture, chemical nutrient cycling and chemical weathering, and biological, mostly talking about organic matter. And soils that tend to have more organic matter or can accumulate organic matter quicker tend to be soils that are more resilient, tend to return back to their previous or similar previous state more rapidly. Okay, why is this important? Well, if you think about today's world, and we've talked about some of these concerns, is today we have increased production, right? Let me get my highlighter. So we're seeing increased production and demand on these systems. Also, we have increased urbanization and then climate change. All of these things are impacting our soils and influencing their efficiency, okay, and changing them, causing disturbance. So all of these are causing degradation and disturbance. Okay, so these are all causing disturbance and degradation of soils. Well, disturbance and potentially degradation. Okay, and so we need to determine what soils are resilient and how maybe to improve the resilience of those soils so that they can withstand, or they can take the change, handle the change. So I've got an example here. I chose to do climate change. That's a common concern. And so how is climate change and soil resilience interacting? And so if you think about this, when it comes to climate change, we do have, oops, a little low there, we do have, a moderate increase in temperature could mean more biological activity, but at the same time, and that might be a good thing because that might add more organic matter to the soil, but also climate change comes with flooding, right? We see more intense rainstorms in areas, which cause more flooding and therefore potentially more erosion. So yeah, there can be a benefit of more organic matter in climate change, but there is also a much greater risk of flood and erosion in some areas. In other areas, it's drought. There's more of a concern with drought and severe drought, which will really reduce the soil's ability to recover. Oops, I kind of crossed that out. I meant to underline it. Recover, right? It will reduce the soil's ability to bounce back. Okay, and so I'll write that down here again. It will reduce its ability to bounce back and really reduce its resilience. In other words, even if conditions climate does go back to normal, the soil's likelihood of returning to its previous state is much less likely because of the impact of drought. Okay, and so soils that are deeper, richer soils have more organic matter, will have more resilience to climate change. In other words, climate change will be less likely to degrade those soils. It disturbs them, right? The key here is climate change definitely is going to disturb soils, but if I've got good soil resilience, so if I have good soil resilience, then we will have less degradation. Okay? If I have poor soil resilience or low soil resilience, then disturbance will occur, but degradation will also occur. Okay? That wraps up our introduction to soil resilience as part of our Session 13 lecture series on soil resilience from Chapter 16.